Hi everyone. Okay, so as we established in the first video, we are going to be moving on to chemical synthesis, which is an important reaction for general chemistry or chemistry 101, or one of the reactions we'll be doing with. So when you say synthesis, the general equation we have, and it's easier for students to understand by modeling this alphabetically, is we have compound A plus compound B yields compound AB. Now, when we say synthesis, is exactly what it sounds like. Like synthesize, you put things together. Okay, so these we model compound A plus compound B coming together to make compound A, and that's literally it. That's all synthesis is. So now let's get on to an example and let's balance the equation. Okay, so in this example, we are going to use some solid sodium plus chlorine gas. Remember, chlorine is one of your 7 diatomic elements. And we're going to yield sodium chloride, which is also solid, just much like sodium. Now, this is done under extreme pressure, extreme temperature in a beaker, but that doesn't matter. We're going to model this as we put a line down there. Remember, we have the reactants here and we have the products here. Okay, so to do this, we're going to list out the atoms that we have for each compound on each side, and that's going to tell you numerically to better understand it such that it models in a mathematical equation. Okay, so we have 1 molecule of sodium here. We have 2 molecules of chlorine here. Remember that 2 right there. And over here we have also 1 molecule of sodium, and over here we have 2 molecules of chlorine. Now, this sodium itself, if you put on our blinders here, sodium does not violate the law of conservation of mass. However, chlorine, there's 1 chlorine here, and there's 2 chlorines here. So what we need to do is, well, obviously on this side we have to multiply this by 2, so we put the coefficient there. So we can think of this as distribution. So if you had sodium times chlorine, and then we put 2 and distribute them as if they were variables in mathematics, then we would get 2 sodiums and 2 chlorines. So we also, along with the chlorine, we would get 2 sodiums. Now we have an issue here. Well, there's 1 sodium here now. We've already established that sodium didn't violate the conservation of mass before, but now it does. So now what we need to do is simply multiply it like that. 2 times Na, just much like 2 times X, is equal to 2X. So this is 2Na. So now we have 2 sodiums on this side, 2 sodiums on that side, 2 chlorines on this side, and 2 chlorines on that side. So we have equal mass going in and equal mass going out. Or in this case, we could say 1, 2, 3, 4 molecules is 1, 2, 3, 4 molecules here too. So we can say the number of molecules on each side is equal, or atoms. Okay, now this did not apply for every case, but it's just a nice way to model it. Okay, so now let's move on to the next example. We have a similar reaction here, but this time we have aluminum. And remember, aluminum is one of our transition metals, whereas sodium was one of our alkalis. So we're assuming we do the same heat reaction where we add kinetic energy to the beaker. The chlorine gas is going to react with aluminum metal to produce, remember your chemical formulas, AlCl3, which is aluminum 3 chloride, and this is going to be a solid. Okay, so now let's just do the whole convention thing. So we draw a line down there to establish reactants and the products. Over here we have 1 aluminum. That's our only atom, right? So for here, chlorine, we have 2. Remember, there's a subscript here. Here we have 1 aluminum, and then 3 chlorines. So we have a problem here. Aluminum is balanced. If you put on our blinders and only look at aluminum, aluminum is balanced, but chlorine is not. And then we also have another problem, that this is an odd number, this is an even number. Now, when you multiply this by 2, you get 4, and that wouldn't work either. So you need to learn or kind of think back to your mathematics where you have a common denominator. And the way to get a common denominator is just to cross multiply these two. Or, yeah, so you put 2 here, 3 here. So we multiply this by 3, which means we put a coefficient of 3 here. And then we would erase this, and then we would have 6 chlorines, because 3 times 2 is equal to 6. And then we would have 2 times chlorine here, which is in the compound aluminum 3 chloride. So we do 2 times AlCO3. And along with the aluminum, we get 6 chlorines. And remember, we put a 2 here because we've also multiplied aluminum in that compound. Okay? And now our chlorines are pretty obviously they're balanced. However, aluminum here is not. And you can see simply that all you have to do is just multiply it, put a coefficient of 2 there. And then we'd have 2 aluminums here. We have equal mass in, equal mass out. Therefore, we would call this equation balanced. Okay? So there is our balanced equation. I will give you one example and I will say goodbye. Okay, so let's review the answer here. So we can always draw a line down there to make things easier for us. For hydrogen, you would get 2, and same thing for oxygen. They're both Hunkelberg elements or diatomic. For hydrogen here, you would get 2, and for oxygen, you would get 1. Now we can see that there is 2 too many oxygens here, and there is too few oxygens over here. So the only thing we could do is put a 2 here, a coefficient of 2. But also remember that 2 times 2 hydrogens is 4 hydrogens, and along with that, so, and then we would get 2 oxygens. So oxygen is balanced, however hydrogen is not, and we just put a 2 here. So 2 times 2 hydrogens is equal to 4 hydrogens. All right, there. Thank you guys for watching. And next we will be going over the decomposition reactions.